Hi friends, welcome to WebCham. In this video, I am going to discuss what is an index and what are the different types of indexes in SQL. So if you are dealing with the database and you are using the data for the analysis purpose, obviously you needs to improve the performance of your report and how you will improve. So this is a part of performance improvement where you have to fetch the data more faster than the normal. So at this point, index comes in picture. So, for example, if we consider a book which has 1,000 plus pages, and if you are looking for a specific topic, how we will go to the page? So obviously, each page has an index. Similarly, we can create. Obviously, our database is going to hold a lot of data. So what we will do, we can create an index so that searching for the data will be easy. So whenever we request a data, database engine should go for the index first. Based on the index, it will be easy for the database engine to find the rows easily. So this is what the purpose of index. But definition is like it is a data structure that improves the speed of data retrieval on a table by allowing database engine to find rows more efficiently. This is what the purpose. As I said, it works similar to the index in a book, where instead of scanning the entire book, you can quickly locate the relevant pages. Right? This is what the purpose of index. Purpose of index in with respect to the book, with respect to the database is same. So we have different types of indexes. First one is a clustered index. Second one is a non-cluster index. So like this, we have many unique indexes there. Composite index is there. Then full text index, bitmap index, filtered index, covering index, spatial index. So these are the types of indexes, but not all will be useful. So these are the first, we can say the main four types that we need to understood. So clustered index. So when we create a primary key or when we define a primary key column, whether it is based on a single column or multiple column values, that will automatically create a clustered index on the database column. So meaning what will happen when we try to filter out the data, when we try to search data for the any specific primary key, so that searching will be more faster. With small data set, you will not be able to feel the difference between time. But if you have a very large data set which has a millions of record, there you will feel the difference with the index and without index. Clustered index actually determines the physical order of data in a table. Let's say you have a employee ID, you made that column as a primary key, then it automatically it will sort the data because of it has created, when we define the primary key, it has automatically created a clustered index. And the way we can have only one primary key in a table, similarly we can have only one clustered index for a table. Not more than one clustered index can be created for a table. Then next is non-clustered index. So this stores the pointer to the actual data instead of storing the sorting the physical data. Meaning, see, when we create a clustered index, that will sort the data, that will store the data in specific order in the database. But when we create a non-clustered index, this will store the pointer to the actual data instead of sorting the physical. This will not sort the data. It will create a pointer, but pointer will consume another memory. A table can have multiple non-clustered index. This is possible. So if you are using any column for the searching purpose, that is for a frequent search, then you can define non-clustered index for that column. Then we have next is unique index. So unique index is used to ensure all the values in the indexed columns are unique. So unique constraint we can apply. That is what going to create a unique index. Or primary key is also going to create a unique index for us. So when unique index is created when we create a primary key or unique constraint, or we apply the unique key constraint for the any specific column, the unique index will be automatically created. Then we have a composite. Composite, you can understand an index which is defined on the multiple columns rather than on single column. So this is useful for querying the queries, filtering on the multiple columns together. Right. So let's see how we can create a clustered index. So this is very important. You should know how to define. So while creating a table, you can define, that is fine. But if you want to define the clustered index later, you will be able to do that. You just have to say create clustered index name. You are supposed to give the name for the index. So how you will identify, because this is not going to store anywhere, you want to be able to see where the index is created and stored. So this is again a database object, but you need to give the name for it, because you won't be able to see this physically on a table name and then column name. So definition is or creation is pretty much simple. So we can say create clustered index name is test. Okay, and on the table name is dbo dot, or let me say sales of, and then column is order id. This is how I can define. Okay, so if I try to run this says incorrect syntax near the order id. Okay, so let me use the round brackets. This has started the execution. This is still, it is creating a clustered index on the sales table, and this is at the running stage. Okay, so this is how we can create the clustered index on any specific column. If you want to create clustered index on the more than one column, you can specify the comma separated list of columns in the tuple. So what is the benefit of the clustered index? Here you can see that faster retrieval for the range based or sorted queries. We can have only one clustered index per table, and when primary key automatically create clustered index unless overridden. Impact performance of insert update delete operation, because it requires reordering a data. So if you are going to perform the update delete and insert operation, so the performance of these dml operations will be impacted. So index is basically used to improve the speed of query, but yes, on the other side it has a disadvantage that it will slower the performance while performing the DML. So this is about the clustered index. Then we have non-clustered index. Non-clustered index, it is not getting created with any specific key. So we need to define this externally or exclusively. We have to define for any specific column. So it's a separate structure for the table that contains the pointer to the actual row. Unlike clustered index, so clustered index define the physical order of data. Non-clustered index improve the query performance by allowing faster lookups. The purpose is same, improve the speed of query, but both the types of index works very differently. One is going to sort the data, another one is going to create a pointer. And you can define the way we have defined the clustered index. So if you go and if you say here, this is like, let me say non-clustered index. So this is a keyword available, you can see. And if I run this, so it will create, but on the same column we can't create. So we need to use the different column, let's say state, and then I can execute. So again, clustered index can be created on based on the non-clustered index can be created on the multiple columns. What is the difference from the clustered index? If you ask me, so here you will be able to see the difference. Clustered index sort and store the data physically in table order. Non-clustered store the pointer to the actual data without changing the physical order. So data will remain as it is. It is not going to change the order, but yes, it will create a pointer to the data. So clustered index is only one per table. We can have multiple non-clustered index per table. Storage, if you ask, so clustered index stores the actual table rows in sorted order. Non-clustered index stores only indexed structure with the row pointers. Performance, faster for the range based queries, meaning if you are giving a range for any specific column to filter out the data, that will work faster with the clustered index. And non-clustered index is best for the frequent searches on non-primary key column. So use case for the clustered index is primary key sorting, range based queries. Use case for non-clustered index is frequent search on the non-primary key column. So with respect to performance, when you have to look up faster when filtering by index column, then non-clustered index is good. Data retrievals directly retrieve the data since it is stored in order in case of clustered index. In case of non-clustered index, needs to look up row pointer to fetch actual data. Now let's see whether it improves the performance for the DML. So clustered index lower the performance while non-clustered index is faster for modifications but require additional storage for pointers. So this is what the difference between clustered index and non-clustered index. Clustered index is created automatically when we create a primary key, and in case of non-clustered index you need to define explicitly. So this is all about the index in database and different types of indexes. I hope you like the content of this video. Thank you so much for watching the video. Have a nice day. Happy learning.